Picture a world that looks alive but isn't. A blue planet with clouds and oceans, where chemistry copies the pulse of life so perfectly it fools even the smartest machines. We see oxygen, water, maybe even the flicker of methane, and believe we've found another Earth. But what if we haven't? What if every sign of life we've detected so far is just the universe playing the same trick it played on us over and over again? In this film, we'll trace that illusion back to its source. From the first spark that awoke on ancient Earth, through the frozen lungs of Europa, to the ocean planets that drown in their own perfection, we'll uncover the pattern that decides where life hides and why it's never where we expect it to be. But before we can understand where life hides, we have to ask a harder question: how it began here, against all odds, on a planet that should never have worked. The shore is not yet a line, but a ragged fever of stone, steaming where water meets heat and heat meets gas. The sun hangs lower than it will in later ages, dimmer, with a light that feels like late afternoon stretched across the whole day. The planet turns quickly, and the day's briefness drums through the ocean in hard pulses. Tides heave like the breath of something sleeping near the surface, each surge dragging a glaze of minerals over black rock, each retreat leaving behind shallow pans that simmer rather than rest. In those pans, the air bites and the water bites back. Acids lace the pools, salts crust their rims, and the rain, when it comes, is not a balm but another reagent in the slow experiment of a young world. Beneath this restless weather, a skin has formed. It is thinner than paper and as stubborn as old paint, a film laid across stone and sediment like a secret someone tried to wipe away and could not. It coats the ribs of basalt, creeps along the undersides of pebbles, and binds grains into a soft varnish that resists the scrub of waves. It does not shine. It is dull, patient, and busy. If it had a fragrance, it would be metal and egg and something faintly sweet that does not belong to fruit. Habits. Where the crust splits at the sea floor, vents pour heat and ash, and the water blooms with gradients, hot to cold, alkaline to acid, rich to poor. At those borders, the thin film finds grip, building layers out of almost nothing. It learns to use imbalance the way a sail uses wind, leaning into the pressure differences, catching energy from the fall of molecules down their slopes. Minerals precipitate like frost, then vanish, then return in new shapes. Pores open and close as if breathing, though there is no breath. The film does not hunger and does not sleep. It follows rules older than appetite and older than desire, and its persistence is its only story. On the tidal flats, the same skin grows low and wide, building ripples that will later be called stromatolites. They look like small domes of lichen that forgot how to be dry land. Each surge of the tide buries them in silt, and each quiet hour they rise again by collecting a new layer over the old, trapping sand with slime, cementing grit with gel. Under a hand they would feel rubbery and fragile, easy to dent, quick to mend. The film darkens with pigments that deflect the sting of ultraviolet light. It learns to harvest a harsher kind of energy when minerals run thin, and the light, though weak, becomes another gradient to tap. Gas bubbles stumble to the surface and break unnoticed. Time is measured here by storms and by the slow drift of continents that have not yet agreed on their shapes. The moon hangs nearer, pulling the ocean into exaggeration, piling water where later it will only nudge it. Each tide drags new feedstock across the flats. Each storm hammers fresh metal from rock. When the sky clears, the world looks flayed and clean, all edges and sheen. with the film stitched to it like a healing scab. Inland, rain collects in bowls blasted into hard stone. The lakes are bitter and hot at their edges, and more temperate a few steps away, a patchwork of temperatures and pH and dissolved riches. The margins are rimmed with the same subtle sheen, the same patient glaze. Under the surface, filaments web from grain to grain. Some days a veil hangs in the air, a faint orange haze that makes the sun's edge blur, a sign that carbon and hydrogen are keeping company in the high cold. The light sifts through this veil and falls gentler on the water, and the pools simmer a little cooler, and the film creeps a little farther up the slope. On other days the veil is gone, and the light bites harder, and the film retreats to the shade under grains and ledges, keeping low, keeping damp. Either way it holds. Down in the deep, at the borders of heat and pressure, other layers accrete on chimney walls, coppery and charcoal, studded with crystals that sprout and dissolve like frost on a window. Fluids snake through mineral labyrinths, and surfaces learn to separate charges, to let electrons leap along tiny paths that feel, at the right scale, like roads and wires. The thin film is not a single thing, but a habit that stones take on when bathed in the right stew. It is not purpose. It is not plan. It is the easiest way for matter to last a little longer before it falls apart. In a future that is not promised to this hour, breath will change the rules. Rust will bloom across seafloors, and the sky will blanch and brighten. And the thin film will invent thicker versions of itself, then taller ones, then ones that run and swim and lean. Today, the world stands on a different knife edge. Here, at the margin of tide and vent and storm, survival means keeping close to rock, skimming energy from falls so small they could be missed by any eye but this one, the eye that never closes and never judges. The film holds. It writes nothing we can read yet except this, that in the chemical weather of a dim young planet, persistence is enough to begin. From those first trembling films of chemistry, the Earth learned its rhythm. But the next breath it took would nearly end everything it had created. The world shifts almost without notice. The same thin films that once fed on darkness begin to toy with light, pulling energy straight from the pale sun and releasing something the planet has never known. The new breath seeps into the air, breath that kills. The planet's mood cools as if in shock. The same light that fostered invention now ricochets off a sky whitening with haze. Methane, the gas that once wrapped the earth in warmth, finds its partners gone, oxidized into carbon dioxide and water, both less able to hold heat. The balance tilts. Rain falls colder. Frost appears where frost has no right to be. Storms move slower but bite harder. Each season presses its chill a little deeper into the crust. The great tides that once scoured the shallows begin to lose their vigor as ice creeps down from the poles. Glaciers edge into the seas, grinding rock to flour, grinding time itself to a slower pace. The oceans respond with long, sighing currents that carry cold into every depth. Under their surface, the rusty snow of iron continues to fall, layer upon layer, sealing the memory of a red ocean that will one day harden into stone. Shadows thicken across the continents. The sky dims to a hard, pale blue by day, silver by night. The sun, half hidden behind high cirrus of ice, scatters light but little warmth. Continents that were once soft with rain bake under a brittle frost. Even the volcanoes seem hesitant, their plumes quickly strangled by the weight of the atmosphere. The Earth, in trying to breathe, has chilled its own blood. In the midst of this new austerity, lakes and shallow seas turn to mirrors. They freeze from the edges inward, trapping the surviving films beneath glassy lids. The trapped layers continue to work in slow motion, harvesting light that filters through meters of ice. Bubbles of oxygen gather beneath the frozen ceiling and explode upward when the shell cracks. Each small eruption adds another puff of gas to the cold sky, another whisper of change. Snow begins to fall on places that have never seen it. Not soft flakes, but fine powder, carrying soot from distant eruptions and the char of lightning-struck dust. Against the whiteness, the dark flecks scatter like ash on bone. In later ages, someone might read those black grains as a clue, evidence of fire or fallout or industry, only the faint whisper of oxygen's ghost. What little remains alive clings to pockets of chemistry untouched by the new order, waiting for the cold to loosen its grip. Centuries stack into millennia, and the ice thickens until mountains drown in it. Pressure drives it outward, grinding bedrock into dust, scouring the face of the planet clean. Beneath, iron stones continue to rust quietly in the dark. The oceans grow pale with dissolved minerals. Their taste changes, their tone muffled as if the entire world has gone underwater. There are no colors now but blue and white and the muted red of buried sediments. No movement but the slow creep of glaciers. The planet looks calm from a distance, but it is the calm of suffocation, the stillness of something holding its breath too long. The very gas that gave the world its first clear sky has stolen its warmth. The Earth is both newborn and dying, brightened and smothered by the same invention. Under that smothering shell of ice, in rare cracks where the cold meets the simmering deep, the thin films persist. They adapt again, drawing what energy they can from minerals and shadows. Their patience is infinite, their chemistry older than hope. They cannot feel the cold, only the imbalance that keeps them moving. Above them, the surface gleams hard and perfect, a mirror to the faint sun. The winds fade, the seas grow still, and for a very long while, the planet sleeps in silence. And the world froze under its own invention. Life retreated underground and waited. What emerged from that silence would be more complex and more dangerous than anything before. The ice does not vanish all at once. It retreats in fits, thawing, refreezing, and sighing apart along ancient seams. Meltwater carves new valleys through stone ground flat by ages of weight. The oceans rise again, shy at first, then reckless, reclaiming deserts of dust. Light returns in full, no longer scattered by ice, but sharpened through a clearer sky. The planet breathes differently now, its air edged with oak, air edged with oxygen, its waters stirred by currents that run deep and strong. Out of that motion, the quiet film that once clung to rock begins. Each gesture answered, each victory temporary. Sediments thicken with the remains of these experiments. The world's first fossils take shape. Tiny imprints of trilobites pressed into silt. Traces of burrows that mark a nervous curiosity about what lies beneath. The seafloor churns for the first time, no longer a static carpet, but a moving mosaic of creatures digging, crawling, feeding. The water grows cloudy with the dust of constant motion. Sunlight scatters through it, forming dancing columns of gold that reach down to where life is busiest. Currents carry larvae far from their origins. Distance becomes another variable in the great trial of forms. The ocean learns to mix its designs, recombining parts that evolved in isolation. Some shapes are fleeting, gone as soon as they appear. Others persist and refine, drawing new lines of possibility. Limbs joint themselves into tools of leverage. Fins broaden into paddles. Bodies stretch and taper for swiftness. The sea begins to look alive in a visible way, crowded and loud, its stillness broken by flurries of motion that leave ripples even in the light. Eyes multiply, first patches of pigment, then lenses, then complex orbs that can track direction and distance. For the first time, the world is not only felt, but seen. Shadows acquire meaning. Brightness becomes warning or invitation. A creature's survival now depends on what it can notice. Vision drives everything to be more vivid, more distinct. Colors bloom under the water, patterns appear across shells, and movement itself becomes language. Predators refine their craft. They strike not from proximity, but from foresight, reading the tension in a ripple before it arrives. The hunted answer by burrowing deeper, camouflaging, splitting into colonies. Some begin to sense vibration or the chemistry of danger. The arms race accelerates, turning necessity into artistry. Armor becomes ornament. Speed turns graceful. Behavior acquires rhythm. The reefs rise like cities, each coral-like organism building on the skeletons of its ancestors, extending architecture toward the light. Between these towers drift clouds of plankton, the silent architects of the future, with the certainty of design that works, but even it is temporary. The rhythm of life has become too quick for permanence. Success breeds pressure. Pressure breeds change. Behind every mastery waits a flaw waiting to be exploited. Sediment rains down constantly, sealing snapshots of this restless era into rock. Millennia later, they will look like a single instant, a frozen bloom of life caught mid-breath. But within that stone, time stretched and contracted unevenly, every pulse of the ocean marking a new test, every extinction opening a door. The Cambrian seas do not know they are famous. They only know motion. The planet gleams now, the continents fringed with green shallows, the air richer and more forgiving. Oxygen, once the breath that killed, has become the breath that builds. It hardens shells, fuels movement, lets muscle and nerve dream of new coordination. Energy runs faster through the circuits of living matter, and with it, the potential for complexity grows without restraint. Far above the water, lightning forks across clouds that no creature has yet seen. Its light flashes over a sea that no longer sleeps. Below, in the blue depths, eyes gleam back at that brightness, following its ghost through the dark. The earth, after eons of silence, has found a pulse. What began as a whispering film on stone has become a symphony of motion, each note feeding the next. The ocean hums with it, life visible, endless, and unaware of the shadows that will one day fall again. The seas had learned to see and hunt, but the horizon still called. Life was about to attempt the impossible, to stand where no creature had ever breathed. The sea does not stop at its edge. It lingers. Each tide leaves behind puddles that glimmer and shrink, little experiments in survival. In those shallows, life begins to feel the weight of air for the first time. When the water withdraws, it leaves behind more than silt. It leaves a challenge, a world that moves slower, burns drier, and breathes differently. The earth in this age smells of mud and minerals, its coasts wrapped in haze and low clouds that drip. Rivers swell with silt from these new roots. The water runs slower, clouded and warm, curling into oxbows where it forgets its path. In those lazy corners, life gathers in fragile theaters, early fish with bodies plated in bone, their mouths exploring mud for breath rather than food. Oxygen in the water grows uneven, rich where currents stir it, absent where stillness holds. In those pockets of stillness, desperation becomes innovation. Gulping at the surface becomes as natural as swimming. The line between air and water, once absolute, starts to blur. The pools shrink as seasons stretch longer and hotter. Evaporation leaves rings of salt and dead algae, crusts that crack like dry skin. At the pool's heart, a fish named Tiktaalik lies half buried in the sludge. Its fins are stronger than they need to be. Their bones hint at another purpose. It props itself against the weight of the world, lifts its head for a breath it should not take, and survives a few heartbeats longer. Muscles meant for steering begin to serve a new master, gravity. It will take ages for this gesture to become a gate, but the first push has been made. Elsewhere, others follow. The shallows swarm with half measures, creatures that can swim better than they can crawl, breathe air only when forced to, see the world dimly above the surface. Their eyes harden against glare. Their scales turn to armor against dryness. In time, the fins that once fanned water begin to hinge, their rays thickening into primitive bones. The rhythm of movement changes from stroke to step. The transition is awkward, graceless, and slow. But persistence wins where perfection fails. Rain no longer falls evenly. It comes in bursts, filling riverbeds and then abandoning them to crack. Pools become traps, then tombs. Those that can crawl or burrow out live long enough to pass the trait forward. Oxygen, once abundant in the sea, now becomes a currency more precious than food. Gills collapse in the air, but lungs, pocketed sacks of chance, expand where gills fail. The debt of breath must be paid differently here. The landscape transforms underfoot. Marshes spread between the roots of the new to keep its chest from collapsing under its own weight. The motion is clumsy, but revolutionary. The land gives no mercy, yet it holds the promise of stillness. No predators, no currents, only space. At dusk, the air cools faster than the water, and mist rises from every hollow. The forest breathes in tandem with the fading light, exhaling moisture and drawing in the very oxygen it helped create. The sounds of this new world are small but numerous. The hiss of leaves in wind, the crack of drying clay, the slow pulse of frogs that have barely begun to exist. The border between sea and land has become a negotiation, not a wall. The planet's skin, once smooth and barren, is now patched with life that stains and shapes it. Rivers turn the soil black, carrying the dead and the living in the same current. Spores drift farther each season, painting valleys with green dust. Fish linger near the surface, testing every breath as though it were a secret language they might one day learn to speak. In the shallows, beneath reeds slick with condensation, the ancient rhythm of tides still hums faintly, guiding hearts that do not yet know it. And somewhere, deep in the silt, a drying pool cracks open under the sun. Within the thin film of water that remains, movement still stirs, slow, patient, determined. The planet holds its breath as if waiting to see if this experiment will continue. Then, quietly, the first creature pushes forward through the mud, leaving behind a wavering trail that the tide will soon erase, but history will remember. Anga. From mud and air came forests and predators, each reshaping the planet in ways it could not predict. Yet this new abundance carried a secret flaw that time would soon expose. Tai. The land settles into a rhythm that feels almost content. Rain no longer arrives as violence, but as routine, mist rising each morning like breath from a sleeping animal. The world hums with a deeper green than ever before. Dense, wet, and relentless. Forests stretch across whole continents, their canopies sealing the air into humid chambers where light filters in fractured gold. The ground, soft with fog, gleaming with condensation. Centipedes longer than a man's arm move through fallen logs, carrying the sheen of oil on their plates. Even the simplest creatures take advantage of the generous air, their cells burning brighter, faster, larger. Every breath is a surplus, every motion easy. The forest hums with flight and creeping, an orchestra of wings and legs and slow decay. Yet the decay itself is the missing note. The wood that falls does not truly die. It persists, layered, preserved by its own chemistry. The air's richness feeds life above, but starves the process below. Fungi and microbes that could break down the thick cellulose have not yet mastered the trick. Trunks collapse and lie where they fall, their interiors filling with silt and peat, their surfaces glossed with algae and moss. Each storm topples more, and the forest floor becomes a map of yesterday's weather. The planet is learning to save what it cannot yet consume. Swamps expand between the roots, black mirrors that swallow the reflections of trees and sky alike. Beneath their surface, the weight of centuries begins its quiet heist. Layer upon layer of unrotted wood settles into the mire, compressed by its own abundance. Water seals it from the air, pressure flattens it. Minerals creep in to replace what softness leaves behind. The forest becomes a vault, its riches hidden not in jewels, but in carbon. Each fallen trunk is a deposit, each drowned branch an investment that will wait hundreds of millions of years to be spent. Rivers wander through this wealth like thieves who have forgotten they are stealing. Their slow currents drag broken stems into deeper basins where the dark water keeps its secrets. Mud buries wood, and wood becomes memory. The planet, without intent, begins to rewrite its balance sheets, pulling carbon from the air and locking it away, cooling itself in the process. The more the forests grow, the more they ensure their own undoing. Above, storms hang for days without moving. Lightning cracks through the heavy air, striking wet trunks that refuse to burn. The rain follows in sheets so dense it's thicker. The climate softens. Oxygen feeds fire as easily as life, and the occasional blaze sweeps through with frightening hunger, burning not as punishment, but as correction. Yet even flame cannot keep pace. The green always returns, stronger, taller, feeding on the very ashes meant to humble it. In time, what lies buried will press tighter, losing its shape, its texture, its color. What remains will be black and hard, the distilled essence of sunlight, long forgotten. Coal is not born in noise or heat. It is composed in silence, under the weight of patience. The world above will move on, its forests shifting, its animals changing. But below, the heist continues in darkness, turning abundance into memory. From a distance, this age would seem endless, a planet wrapped in green breath, water and air trading secrets through mist. But the cycle is unbalanced, and imbalance is never still. The forest that would not rot has stolen too much light, trapped too much life underground. The air, fat with oxygen, waits for something to spark. The earth inhales heavy and full, unaware that its next breath will come out as fire. The world grew rich and heavy with its own success, until the balance snapped. What followed would erase nearly everything that crawled, swam, or flew. The end does not come as a single blow, but as a long unraveling. The green hush of the Carboniferous fades into a harsher rhythm. Continents collide and buckle, raising mountains where shallow seas once breathed. Volcanoes split the crust in lines that stretch for thousands of kilometers, their mouths spilling sheets of basalt that steam as they meet the air. The sky bruises with dust and sulfur, and the sun becomes a dim copper disk hanging above a restless horizon. The planet exhales heat faster than life can adapt. At first, nothing seems terminal. The forests thin but persist. Rivers still wander, though they run darker. Yet beneath the surface, balance begins to slip. The seas lose their oxygen, their depths turning from blue to green to black. Bacteria thrive in the still water, feeding on decay and exhaling toxins that rise through the layers. Carboniferous begin to falter. Rain falls acid, scouring bark and leaching soil. Roots lose grip. Rivers choke on silt until they run shallow, and the wetlands that once sheltered amphibians shrink into stagnant pits. The air still holds its oxygen, but each breath tastes faintly of ash. Insects fall quiet, their wings stiffened by heat. Reptiles venture farther in search of food, only to find the world thinning around them. The great tree ferns wither into brittle silhouettes, their spores settling uselessly on lifeless ground. Far to the north, the volcanic fields continue their slow work. For centuries they ooze rather than explode, exhaling carbon and sulfur in equal measure. The gases drift across the planet, spreading a haze that turns daylight into dusk. Temperatures swing without warning, scalding one decade, freezing the next. Seasons lose their order. Drought grips one hemisphere while torrents drown the other. The fabric of predictability, upon which every web of life depends, tears apart thread by thread. In the oceans, the deep turns stagnant. Anoxia creeps upward from the abyss like a tide that will not retreat. Fish vanish first, then the soft-bodied creatures that fed on their remains. Trilobites, survivors of every previous trial, blink out after 300 million years. Their absence is so complete that only impressions in stone will remember them. Above the lifeless depths, the surface gleams with oily calm, reflecting a sky that seems too bright for the silence below. The end of the Permian feels less like death and more like forgetting. Patterns that once repeated across generations simply stop. Species disappear not with spectacle, but with a hush, each failure unnoticed by the next. The few that endure are scattered, burrowers that hide from heat, scavengers that feed on the last decay, small opportunists living in cracks and shadows. For a moment, it seems as if the earth has chosen to erase itself and start over. Centuries blur into millennia, and still the volcanoes breathe. Their exhalations tip the climate from one extreme to another. Oceans turn into vats of chemistry, stripped of circulation. Their surfaces glazed with stand where the lava cooled, their flanks veined with black glass. Rivers carve new paths through ash, searching for their old courses. The sky, once red, fades to pale blue, its brightness returning as if nothing had happened. But the silence beneath that sky is profound. The world waits, empty but expectant, holding its breath for the next experiment to begin. Out of that devastation, the earth began again, hotter, stranger, and full of opportunity. The next age would build its wonders on unstable ground. The quiet after the Permian feels fragile, a thin pause stretched across millions of years. Then, slowly, the world begins to move again. Air warms, water stirs, and the bruised surface of the earth greens over in patches. Life returns, not with haste, but with caution, as if testing whether the planet still allows it. Reptiles rise first, filling the silence with scales and muscle, their shapes broadening into new hierarchies of motion. Forests take root again along coasts and rivers, while deserts expand inland, stitched together by long threads of wind. The world is still recovering from its own forgetting, but it begins to remember how to live. By the time the Mesozoic takes its form, the continents have drifted into new alignments. Oceans thread between them like veins of heat. Volcanoes still speak in low murmurs, releasing carbon that thickens the air just enough to tip the balance toward warmth. But it is not an endless summer. The image of one vast tropical world is an illusion, a trick of hindsight. The planet has grown more complicated, its climates layered and restless. At the equator, heat presses down so fiercely that rain comes only in violent bursts, leaving wide belts of red dust and cracked salt. Toward the poles, strange forests bloom under pale light, their seasons out of step with the rest of the earth. In the north, conifers rise in disciplined ranks, their needles collecting dew from the long twilight. Softens but does not fade, forests spread wide and patient. Giant ferns unfurl their fronds like banners, ginkgos shimmer silver-green in the sun. Between the trunks, smaller lives hum, flies, beetles, the first bees, their wings flashing like fragments of mica. Flowers, still a new experiment, open in reckless color, each petal a gamble on the wind. Pollen drifts across continents, a golden fog that feeds the air itself. The ecosystem is no longer a single chorus, but a layered orchestra, each climate playing its own measure. Toward the poles, warmth lingers where it should not. Summers stretch long and strange, with the sun circling the horizon but never falling. Pines and ferns coexist uneasily, sharing light that fades but never disappears. Winters bring darkness, yet frost rarely reaches deep enough to kill. The ice that forms at night melts by noon, leaving the ground slick and steaming. The earth in these latitudes feels confused, as if its axis were a suggestion rather than a rule. Inland, the deserts widen. Wind shapes dunes into migrating ranges, their peaks whispering as they shift. Reptiles adapted to drought leave trails that last for decades before a single storm erases them. Above, the air vibrates with heat so dense it bends light, turning the horizon into a trembling mirage. Yet even here, life hides, burrowed in sand, coiled in shade, waiting for the cool of dusk. When rain does come, it transforms emptiness into sudden bloom. Crusts of cyanobacteria paint the ground blue-green, fleeting as breath. By the late Cretaceous, the balance tilts again. The warmth deepens, sea levels rise, and the continents fracture into islands of humidity. Grasses appear quietly in the margins, thin, patient blades pushing through the mud along riverbanks. They do not look revolutionary, but they begin to stitch soil together in ways unseen. Their roots hold the earth against flood and drought alike, binding dust into fertility. With them comes a new war, unseen and unstoppable, preparing a foundation that will outlast the giants who walk above it. The heat at the poles will fade, the drought at the line will break, but the quiet weave beneath, the patient engineering of soil, will remain, waiting for the next story to grow. Even as the continents shifted and giants ruled the heat, something smaller was preparing in the shadows, waiting for the world to quiet once more. The world ends not with noise, but with a shadow. It passes quickly, a moment stretched thin across the planet, and then everything changes. The seas lift in slow disbelief, the forests ignite, the air thickens with the taste of dust. For a while, light itself feels uncertain, filtered through a haze that never settles. When the sky finally clears, what remains is quieter than silence. The age of giants has collapsed into stillness. The continents hold their breath. The ground, once trembling under herds and wing beats, lies empty. Mountains look sharper now, their outlines no longer softened by jungle. Rivers run slower, carrying ash instead of silt, as if even water has grown cautious. The sound of wings is gone, replaced by the whisper of wind through fern and grass. Where forests burned, the earth gleams in patches of glass, the mark of heat so fierce it melted the sand it struck. In this vacancy, time changes texture. It no longer gallops, it crawls. With the fall of the old order, the planet seems smaller, more fragile. The loss is total enough to feel deliberate, as if the earth has swept the board clean to consider a new design. The creatures that survive do so by accident, small, hidden, forgettable. They do not rule, they endure. Beneath the ash, seeds begin to stir. Plants return first, humble ones, moss, fern, grass. Their roots press into the soft ruin, breaking what is burned into soil again. Life never asks permission. It simply fills what is empty. Green returns to the blackened ground in thin strokes, a cautious recoloring of the planet. Soon insects follow, wings iridescent against the pale sky. Feed continents. Emptiness becomes opportunity. Without canopy or predator, light reaches places that never saw it before. Valleys bloom. Mountains, bare and scoured, collect pockets of moss that will one day become forests again. Evolution, unhurried, takes stock. In the absence of roar and thunder, patience becomes the dominant force. The mammals change slowly, not by ambition, but by accident. Those that gnaw learn to climb. Those that climb learn to glide. A few discover warmth in community, their small bodies huddled together against cold nights. Fur thickens, hearts quicken, and the architecture of survival grows more intricate. It happens in silence, over epochs of experimentation, while the earth rebuilds its confidence. Each rainstorm draws color back into the soil. Each new sprout reclaims a fragment of memory. The air warms, and with it, curiosity stirs again in muscle and bone. Eyes widen, legs lengthen, lungs deepen. The planet is learning to dream differently. It no longer builds for scale, but for sensitivity. Ears that hear higher, hands that feel finer, minds that remember longer. By the time the forests return in full, their architecture has changed. Trees no longer climb endlessly. They spread, creating layered canopies of shade and fruit. The world hums again, not in the thunder of giants, but in the murmuring complexity of smaller lives. Every leaf trembles with hidden motion. The predators that reappear are cautious, slim, quick. Nothing claims dominion for long. Every throne is borrowed. Above the plains, the air turns blue again. Wind scours away the last of the dust. On the horizon, Dawn comes quietly, without announcement, as if it has always known it would. The age that follows will be defined not by power, but by persistence, the slow, deliberate work of rebuilding. The planet no longer needs spectacle. It has found, in the hush after ruin, a subtler way to begin. When the giants vanished, silence became invention. From that emptiness, tiny hearts began to beat faster and would soon reshape the earth again. The record of the earth is came. The land, meanwhile, blooms unchecked, green triumph built on blue ruin. It will take millions of years for the balance to even remember what it was. Then comes the Permian, the ledger's blackest page. Volcanoes write their entries in smoke and sulfur, each eruption another subtraction. Oxygen plummets, heat smothers. Forests turn to charcoal and the oceans to brine. 90 out of 100 species are crossed out in a single breath of geological time. The rock that seals them in is thick with ash, a gray punctuation mark ending an age. Beneath it, the trace of the great dying glows faintly in infrared. A fever captured in stone. The Triassic tries to rebuild on what remains. New architectures emerge, bones built for speed, lungs built for dryness. But recovery carries its own curse. The survivors multiply into niches that cannot hold them. Climate flickers between drought and flood, heat and chill, as if the planet cannot decide what it wants to be. Then, another silence. The next wave, smaller than the last but sharp enough to reshape everything again. Each extinction narrows the vocabulary of life, even as it teaches what endurance means. Through these layers, a pattern emerges. Rise, flourish, collapse, repeat. The fossil record becomes an account book of excess and correction, a rhythm measured in losses rather than gains. Life expands until it overreaches, then the planet balances the equation. The pattern is impartial, mathematical, serene in its cruelty. To the rocks, tragedy is simply equilibrium restored. And yet, even as the earth erases, it preserves. Each vanished world leaves shadows for the next to learn from. The Cambrian's sudden bloom. The Devonian's experiment with limbs. The Permian's failure to breathe. Each becomes a lesson embedded in carbon and limestone. Every extinction makes space for new imagination. The planet is both executioner and teacher, cycling through its own mistakes until they become the foundation for something else. The story could have ended there, but the present settle over the old strata, a new archive waiting to be named. When the next readers, whoever or whatever they are, cut through it, they will find our time recorded as a brief, bright spike in chemistry, a line of metal and soot marking the moment when we mistook motion for progress. The planet will recover, as it always has. It will need only patience, and patience is what it has most. The counting of the lost is never finished. It only pauses between verses. For now, we are the ones holding the pen, writing the next line into the stone. Whether it ends with silence or renewal remains unwritten. Each extinction wrote another rule into the stone, and those rules will guide us now, as we look beyond this planet to worlds that might share its script. The rules are simple, but not easily met. Life, as the Earth has proven, requires only three things: a solvent to move the pieces, an energy source to stir them, and a chemistry willing to cooperate. Everything else is ornament, refinement, or accident. Water has been our solvent, clear, abundant, loyal under pressure. It dissolves, transports, and persuades matter to converse with itself. Energy comes from imbalance, light falling unevenly, heat rising from within, currents colliding in storms or deep-sea vents. Chemistry is the art between them, the endless negotiation of carbon, hydrogen, oxygen, nitrogen. Letters rearranged into stories that never repeat. On Earth, the combination seems obvious now. Oceans provided the stage, sunlight the spark, and minerals the script. But each component is contingent, balanced on chance. Water must stay liquid, not boil or freeze entirely. Energy must be strong enough to build, but not destroy. Molecules must collide often enough to learn. The conditions are narrow, the outcomes improbable. Yet here we stand, the result of coincidence made stable through time. The planet itself acts as a patient laboratory. Oceans mix with continents, pulling elements from stone, washing them. Bands stain the continents, auroras fringe the poles. From orbit, these are the visible proofs of balance, the coexistence of warmth and cold, motion and stillness, ocean and sky. The chemistry of life announces itself not through single details, but through harmony. Gases out of proportion, colors that imply metabolism. A hum of imbalance maintained for billions of years. Beyond this sphere, other worlds wait in shadow. The outer system gleams like a gallery of experiments. Moons of ice, planets of gas, oceans buried beneath crusts of frost. Their distances are immense, but their materials familiar. Jupiter looms there, a furnace wrapped in storms, its gravity shepherding dozens of satellites into eccentric orbits. Around it, conditions repeat themselves in variations: rock and water, heat and cold, pressure and silence. The pattern that worked once might work again. If life is chemistry in motion, then motion itself is the key. Every planet, every moon is a different version of that motion: rotation, orbit, tide, or temperature gradient. The solar system is less a family of bodies than a network of experiments running in parallel. Some failed early, boiling dry or freezing solid. Others may still be halfway between possibility and proof. The task is to listen, to look for signatures of imbalance. A trace gas too abundant, a surface too smooth, a glimmer of liquid where there should be none. Earth's lesson is humility. It shows that life does not require perfection, only persistence. It thrives in acid and ice, in pressure and drought, wherever chemistry has the courage to continue. The boundary between living and not living is thinner than any membrane, a shimmer where energy lingers long enough to matter. The camera lifts from the blue marble and keeps rising. The continents shrink into pattern, the clouds into motion, the ocean into color. Above the atmosphere, the stars no longer flicker. Between them lie countless worlds turning in their own patience, each following the same quiet rules, each waiting for a spark. The ingredients are simple: water, energy, chemistry. Child. Its surface is raw motion, a crust of sulfur and rock, perpetually torn open by tidal strain. Volcanoes rise and vanish in a single decade, pouring molten color across plains of ice-cold shadow. Jupiter's gravity kneads it constantly, turning its interior into liquid stone. From orbit, It gleams like a wound that never heals, its surface repainted each year in yellows and reds. Io is proof that even in deep cold, heat can find a way to escape. Farther out, Ganymede carries its own secret furnace. It is the largest of the moons, bigger than Mercury, a world with gravity enough to shape an atmosphere, thin but loyal. Beneath its crust lies an ocean layered under ice, perhaps salt water laced with minerals leached from its rock. A metallic core spins deep within, generating a magnetic field, the only one of its kind among moons. Aurora curtains shimmer along its poles, interacting with Jupiter's immense magnetosphere in a slow electrical duet. Ganymede feels ancient but alive, a laboratory of pressure and magnetism, where energy and water coexist in uneasy truce. Its valleys and ridges stretch for thousands of kilometers, like wrinkles on a planet that once tried to move and then froze mid-gesture. Beyond it drifts Callisto, the quiet archivist. Older than any other surface in the system, it bears every scar it has ever received. Impact craters crowd each other so densely they merge, a record written in stone that was never erased. Unlike Ganymede, Callisto's interior sleeps. It has no magnetic heart, no tectonic restlessness. Its ice crust is thick and stagnant, preserving a billion years of stillness. But beneath that outer calm, evidence suggests an ocean, trapped, unmoving, insulated by time. If Ganymede is a laboratory, Callisto is an archive, storing the unedited history of bombardment and endurance. It remembers what the solar system has long forgotten, how violence became landscape, and how still part in the long rehearsal of creation. Jupiter's gravity binds them in rhythm, forcing them into precise resonance. As one completes an orbit, another completes two, another four. The result is a dance of tides that stretches and compresses their interiors, turning friction into warmth. What the Sun does for planets, Jupiter does for moons. Energy, though borrowed, flows freely through the system, sustaining storms, melting ice, keeping oceans from eternal sleep. From afar, Jupiter's domain glows faintly, a lantern of motion in the dark. Its magnetic field reaches millions of kilometers into space, sweeping charged particles like wind through unseen sails. Every moon inside that reach carries the mark of its parent's power. Auroras on their poles, static in their airless shadows, echoes of radiation whispering across their surfaces. To cross that realm is to move through a storm that never ends. This world within worlds is both echo and promise. It shows that life's conditions, heat, water, chemistry, need not be confined to a single planet. Energy can be tidal instead of solar. Oceans can hide beneath ice instead of sky. And warmth can come from gravity's relentless pull. Jupiter radiates and its moons respond, each a chapter in a story older than habitability, younger than certainty. The giant planet keeps no secrets, yet its children hold them all. Fire, memory, water, and the quiet persistence that turns orbit into destiny. Fire, water, memory, and silence. Jupiter's moons repeat our history in miniature. But one of them, Europa, whispers loudest through its frozen skin. Europa glides in darkness, its skin pale and bright as bone. From a distance, it seems silent, frozen, motionless, a perfect sphere of ice reflecting Jupiter's faraway storms. But up close, the surface tells another story. The ice is laced with scars that refuse to heal. Crimson lines cut across the white plains in tangled loops, curling around the globe like veins beneath translucent skin. They trace fractures that open and close, pushed by the tides of Jupiter back as snow. They appear in pulses, repeating with the moon's orbit, timed like the slow heartbeat of a living thing. Instruments watching from afar detect traces of oxygen and hydrogen, evidence that the water below is splitting in the touch of sunlight or radiation. Oxygen escapes into space, a steady, quiet leak that replenishes the moon's whisper-thin atmosphere. The rest settles back, cycling endlessly between ice and ocean. The chemistry inside that ocean is anything but simple. Salts, leached from rock, mix with oxidants made at the surface by Jupiter's radiation. Each tidal squeeze grinds minerals against one another, releasing heat and trace metals. The result is a restless stew, cold by our standards, but warm enough to flow, reactive enough to dream. If the same rules apply here as on Earth, where water meets rock and energy moves through gradients, then the conditions for chemistry's great leap are present. It does not mean life exists, but it means life is possible. Europa's surface glows faintly in Jupiter's reflected light. Its plains shimmer with frost, its ridges cast long shadows across the ice. Beneath that crust, the ocean could be 100 kilometers deep, sealed away from stars and air. Yet, even there, the interplay of physics and chance continues. Hydrothermal vents may line the ocean floor, spewing warmth into the dark, creating currents that rise and fall like weather in a buried sky. Tiny grains of iron and silica drift through the water, settling slowly over eons. If anything stirs in that vast, hidden sea, it would live without light, feeding on chemistry alone, blind and enduring. The cracks above act as messengers. They link the deep to the surface, trading material between realms. Oxidants produced in the upper ice, by radiation splitting frozen molecules, sink into the ocean through these seams, bringing energy to places sunlight will never reach. Each fracture is a bridge, a narrow lung connecting two worlds, one frozen, one liquid. Through them, the moon breathes in silence. The instruments that watch from orbit capture fragments of this exhalation. They read the faint fingerprint. Destruction feeds the cycle. The idea is tempting. A moon that breathes, an ocean that endures, chemistry that repeats itself until it begins to mean something. But no evidence yet proves the existence of life beneath the ice. There are no signals, no shapes, no movement beyond the rhythm of tide and fracture. The story remains unfinished, its answer suspended between hope and caution. Yet the clues are persistent. Heat where there should be cold, salts where there should be purity, oxygen escaping where none should form. Patterns that repeat not randomly but rhythmically, as if following some internal logic. In science, such patterns are promises. Europa offers one with every breath of its ice, every crack that opens, every plume that fades into space, every pulse that suggests the line between the living and the not living is thinner than we imagined. The moon turns through Jupiter's light, pale and distant, its scars glinting red against the white. From afar, it seems asleep. But in the deep water below, the planet's gravity keeps the ocean stirring, the heat flowing, the chemistry alive. And as the camera drifts upward, the scene narrows to a single thought. If breath can exist without lungs, and rhythm without heart, then maybe life can exist without witness, waiting beneath the ice for someone to listen. Those fractures hint at oceans and chemistry, but proof remains out of reach. To find it, we'll need better eyes and a patience that spans decades. Some worlds are nothing but water. They drift in darkness, far from their suns, or too close to them, wrapped in steam or buried under ice. Astronomers call them ocean planets, globe-spanning seas without continents, without beaches, without pause. From a distance, they glimmer like sapphires, smooth and flawless. But up close, they are something else entirely. Their beauty hides a physics that bends toward cruelty. Imagine standing on one of them, if standing were possible. There is no land, no solid horizon, only endless motion. The sea stretches in every direction, a mirror of cloud and vapor. The surface roars under constant storm. Waves climb mountains high, merging with clouds that are themselves made of water. The world drowns in its own abundance. This is the paradox of the ocean planet. Too much of the right ingredient becomes a flaw. On Earth, water is punctuation between continents, a system of exchange. On these worlds, it is the entire sentence, an unbroken medium that isolates rather than connects. Without shallow basins or tidal shores, there are no gradients, no habitats that dry and flood, no chemistry that can rest, then resume. The sea becomes a closed equation, eternally solvent, eternally sterile. Gliese 1214b may be such a place. Twice the mass of Earth and swathed in a vapor shell, it orbits close to a small, dim star. Its days are longer, its heat uneven, its light more red than gold. Models suggest that its upper atmosphere glows with steam, an immense pressure cooker lit from within. Deeper down, clouds condense into rain, then fall into an ocean that has no end. But as the weight increases, temperature does not drop, it climbs. Water boils under the pressure that should freeze it, and the layers turn to liquid fire. Some call it a steam world, a planet in perpetual evaporation, half cloud, half sea. No one knows if the ocean touches rock. It may end instead in high-pressure ice hundreds of kilometers thick, a mantle of solid water denser than granite. If so, the chemistry beneath it lies imprisoned, unable to mingle with what floats above. There could be lightning storms that never reach a surface, hurricanes that last centuries, rain that falls upward in convection loops. Gliese 1214b is a world defined by motion but lacking memory. Each molecule of water rises and falls endlessly, but nothing solid remembers the exchange. From a scientific distance, such a planet reads like a case file. Mass approximately twice Earth's, radius 1.5 times larger, equilibrium temperature near the edge of endurance. Density lower than rock, but higher than gas, implying a bulk of water and volatile elements. Spectrum dominated by vapor, with hints of hydrogen and oxygen, but no stable markers of land. It is a polished lens. But that calm is deception. Beneath the brightness lies pressure, noise, and isolation. The water hides everything, even itself. Gliese 1214b spins through its orbit in slow dignity, its storms flashing unseen, its heat trapped behind walls of vapor. It is an ocean without shores, a sea that never ends, a mirror of our own planet turned inside out, a reminder that the recipe for life depends as much on the spaces between ingredients as on the ingredients themselves. Even too much of the right element can undo life. So how do we know what's enough? The answer begins with how we search and the tools we've built to see what can't be seen. They began as watchers, not travelers. Long before humanity could reach another world, it learned how to notice them by the smallest flicker of light. The stars themselves became instruments, each one holding in its brightness the trace of a passing world. The Kepler telescope was built for that patience. It stared at a single patch of sky for years, never blinking, measuring the light from more than 100,000 suns. The work was not glamorous. It was repetition, refinement, waiting for the faintest dip, a shadow crossing a star, a planet blocking one part in 10,000 of its glow. Kepler's eyes were not lenses but an array of detectors, so sensitive they could feel the temperature of starlight. Each pixel carried a heartbeat of noise, cosmic rays, dust motes, the gentle shiver of electronics. The data came down in waves, light curves like breathing patterns, rhythmic and imperfect. Somewhere in those fluctuations lay entire systems, planets orbiting, eclipsing, tugging at their suns with invisible hands. The telescope never saw them directly, it only read their absence, the whisper of a planet stealing a fraction of light for a fraction of time. On Earth, teams of analysts turned those whispers into evidence. They plotted graphs where the star's brightness dipped, then rose again with clockwork precision. A repeating pattern meant an orbit. The depth of the drop revealed the planet's size, the timing, its distance, the star's color, its temperature. With every confirmed transit, the map of the galaxy grew. Kepler found thousands of rather than deeper. Where Kepler studied one narrow field, TESS scans nearly the entire sky, sector by sector, like a camera panning slowly across the cosmos. Its detectors watch the brighter, nearer stars, the ones whose planets might one day be visited. It sees the same dimming, the same delicate eclipses, but with more light to work with, less noise to fight. Each sector produces new light curves, rippling lines that tell of orbits, rotations, and shadows. The method is simple, but its precision is a kind of art. Every 2 minutes, TESS takes a snapshot of the stars within its frame. The cadence is steady, mechanical, endless. The data stream fills with minor imperfections, thermal drifts, stray cosmic flashes, the heartbeat of the spacecraft itself. Ground teams clean the patterns, like restorers brushing dust from an ancient fresco, revealing the faint dips beneath. Each discovery begins as doubt, a single dip too slight to trust. Then another and another, matching in time. Slowly, the pattern resolves, a planet, confirmed by patience rather than sight. The results arrive as constellations redrawn by evidence. Small worlds orbiting red dwarfs, giants brushing the edges of their stars, systems locked in resonant chains like celestial music. The light curves are their fingerprints, each one distinct, each one a small confession of presence. The data no longer surprises scientists, it reassures them. The universe behaves as expected, filled with planets, almost casual in its generosity. TESS's success is measured not in pictures, but in rhythm. Its instruments count the seconds between dimmings, building a catalog of intervals that describe everything from hot Neptunes to temperate Earths. The spacecraft's orbit around Earth is highly elliptical, looping far beyond the Moon before returning to downlink its results. It spends nearly half its time in silence, collecting starlight in a continuous heartbeat. The quiet is its work. Together, Kepler and TESS form a relay of attention, one gazing deep into the unknown, the other sweeping the nearby stars. They are surveyors of darkness, tracing what cannot be seen by what briefly it records is another whisper from the dark, a reminder that discovery now begins not with seeing, but with noticing what vanishes for a moment, and knowing that absence means something is there. Their data pours in, a whisper of light, a flicker of shadow. But to read those signs without deceiving ourselves, we must remember how easily the cosmos can lie. The star is small, red, and restrained. It burns with the quiet persistence of age, its light steady but thin, more ember than flame. Around it move 4 known planets, each locked in predictable rhythm. The third of these, catalogued as TOI 700d, circles at the delicate edge where warmth can coexist with water, a temperate band narrow as a breath. It is a candidate, not a promise, a world that sits precisely between enough and too much. The star's calm is its gift. Red dwarfs are known for temper, flaring without warning, but this one rests in long, even pulses. Its spectrum shows stability, its radiation soft. For any planet nearby, that restraint means time. Time for air to form, for oceans to linger, for chemistry to practice its routines without constant interruption. Yet the quiet comes at a price. The light it gives is weak and red-shifted, a glow that would paint the world in perpetual dusk. Photosynthesis, if it ever begins here, would learn another palette entirely. TOI 700d completes an orbit every 37 days. Close enough for the star to fill its sky, close enough that gravity has likely seized it, locking one hemisphere in eternal daylight, while the other freezes beneath stars that never rise. Between those two realms runs a terminator, a line of twilight stretching around the planet, a belt of moderation where day and night share custody. It is here, if anywhere, that stability might survive. Climate models suggest a fragile equilibrium. On the day side, heat builds without mercy. On the night side, it escapes into space. Winds rush between them, transporting warmth as best they can, shaping storms that never stop. Clouds could gather along the twilight band, bright enough to reflect sun warmth. Water vapor might rise and fall in a steady cycle. Too thin and the planet becomes brittle, its night hemisphere frozen, its day burned raw. Too dense and pressure smothers any chance of delicate chemistry. The instruments we have cannot yet decide between these options. The light curve tells us size, mass, orbit, but not breadth. We see only its shadow, precise and patient, crossing its star with mechanical grace. From space, the world would appear muted, a sphere of rust and smoke under a cool red sun. The terminator would gleam faintly, a ring of soft reflection circling the planet like a halo. There would be no blue oceans, no white clouds rolling over continents. It is not Earth's twin, but Earth's thought experiment. What happens when the conditions almost match, when balance is achieved by tension rather than comfort? In the silence between data transmissions, scientists debate possibilities. Could the planet's magnetic field survive such proximity to its star? Could a global ocean, if it exists, circulate enough heat to prevent freezing? Each model ends the same way, on the knife edge of uncertainty. Life here, if it ever begins, would not resemble life as we know it. It would adapt to a world that never moves past dusk, where every hour is either sunrise or sunset, and survival depends on staying precisely in between. TOI 700d is the kind of world that teaches restraint. It reminds us that habitability is not abundance, but balance. The star gives just enough energy to make the question interesting, not enough to make the answer clear. The planet orbits quietly, neither promising nor denying. From afar, it looks like peace, but up close it would be struggle, a world forever suspended between comfort and catastrophe, spinning exactly on the edge of the temperate band. A planet poised between dawn and night shows us how narrow the line really is. It's a lesson in balance and the warning of how fragile habitability can be. In the darkness beyond Earth's pull, a new generation of instruments waits, not to declare discovery, but to open doors. Each one is built around a kind of patience, an acceptance that answers will come slowly, perhaps too slowly for those who ask. They are not ships of arrival, but of attention. Instruments split light into spectra, turning color into code. Each dip, each rise, is an ingredient list of the universe. From that data, scientists can infer temperature, pressure, composition, the fingerprints of chemistry. But spectra tell only what is there, not why. They reveal presence, not process. A line in the data might mark a volcano, a storm, or a living cell. The telescope cannot say which. Webb's strength is its precision. Its weakness is interpretation. It is a key, not a revelation. Farther away, another mission travels toward Jupiter. JUICE, the Jupiter Icy Moon's explorer. It carries a different patience, one that measures time in years of flight. As it coasts through deep space, sunlight fades, and the solar panels, wider than any wings, gleam like black silk. It feels no wind, only the constant pressure of photons pushing faintly against its skin. Inside, instruments sleep and wake in sequence, adjusting to the cold that will be their companion for decades. JUICE will orbit Ganymede in the end, mapping its magnetosphere, tasting its exosphere, searching for the subtle warmth that hints at motion beneath the ice. It is a voyager into silence, designed to study not life, but the environments that might allow it, the laboratories of possibility around Jupiter's immense gravity. Trailing in its wake, another craft prepares for a closer dance, the Europa Clipper. Built to skim a world of fractures and hidden oceans, it will sweep past Europa dozens of times, each pass another conversation between machine and moon. Its radar will peer through the crust, measuring thickness. Its spectrometers will analyze salts ejected by geysers. Its cameras will trace the red lines that seam the ice. Each orbit will bring it closer, yet never enough to land. It will circle and retreat, gathering pieces of truth without touching the surface it studies. Together, Webb, JUICE, and Clipper form a kind of trinity of observation. One anchored to stillness, two committed to motion. Webb watches from afar, reading light from systems that may never be visited. For patterns that resist randomness, they learn to celebrate anomalies that last, repeated signals that hold their shape through noise. Discovery here is a form of patience, an act of endurance measured in orbits and transmissions. In this slow work, hope takes a quieter form. Webb's mirrored eye, the sensors aboard JUICE, the radar of the Europa Clipper, each is a window we will open, not to see life, but to see where life might belong. The first view through those windows may not show oceans glowing or microbes drifting in brine. It may show only chemistry behaving strangely, physics leaning toward complexity. That will be enough. Every question answered by these instruments will create two more, and the waiting will continue. Out in the dark, the machines drift along their assigned paths. Webb hangs between gravity wells, orbiting nothing, watching everything. JUICE moves outward, its long solar panels drinking the faint sunlight at Jupiter's edge. The Clipper waits for launch, folded and silent, its sensors dreaming of ice. None of them will see what their data means. None will witness the conclusions drawn from their work. They exist for others, for the eyes that will one day look through the windows they have opened and recognize, perhaps, a familiar light reflected from another sea. Africa and probe brings us closer, but the universe speaks in riddles. The next clue might not confirm life. It might teach us humility first. The data looks convincing at first. A faint absorption line at the wavelength of methane, another for oxygen, the ghost of a third for water vapor. They line up neatly on the screen, each one a pulse of light filtered through alien air. For a moment, the room where the data is studied goes still. The instruments, 500 million miles away, have caught something that looks alive. The temptation is immediate, to name it, to claim it, to imagine breath in the numbers. But patience interrupts. The pattern may not mean what it seems. The history of science and of Earth itself is full of false positives. Methane, for instance, can come from life, but also from rock, from vents, from sunlight splitting molecules in the upper air. Oxygen build worlds from shadows, to sculpt hypotheses out of incomplete brightness. Earth's own record is a cautionary tale. Long before complex life, the planet's air filled with oxygen, not from creatures, but from cyanobacteria so small they barely counted as alive. Their bloom poisoned the atmosphere, freezing the oceans, nearly erasing the life that made it. Oxygen, once a signal of vitality, became a mark of extinction. Later, methane spiked during mass die-offs, not because the planet was thriving, but because it was digesting itself. Every great turning in Earth's history left chemical ghosts that would mislead a distant observer. A telescope pointed here, from far away, might mistake disaster for awakening. Even water misleads. The blue oceans that define our planet are not permanent. They were once vapor, and will one day boil away. Ice caps mimic lifeless worlds. Deserts hide microbes in crystalline salt. The presence of liquid is not the presence of life. It is merely the setting, not the scene. From orbit, all looks possible. From the ground, everything is conditional. The further we look, the easier it becomes to project ourselves into the data. A thin band of oxygen becomes a forest. A shimmer of methane becomes a city of unseen engines. The mind fills the gaps between numbers with stories. And those stories grow faster than evidence. Each new discovery carries the ghost of the old wish that we are not alone, that we will recognize ourselves in someone else's chemistry. But every lesson from Earth whispers the same warning. Resemblance is not relation. The scientists know this, though they too feel the pull of wonder. Their notebooks are full of caveats, their graphs annotated with caution. They know that geology can imitate biology, that heat can mimic metabolism, that the universe rehearses the same tricks endlessly. To detect life at a distance is to translate a language without ever hearing its words. The alphabet is familiar, but the syntax is unknown. Somewhere in the records of past missions lies a photograph of Mars from the 1970s, a simple patch of soil under a pink sky. Instruments then detected a whiff of gas that behaved like must live beside restraint. That discovery begins with skepticism, not certainty. The cosmos is subtle. It hides meaning inside mimicry, teaches through confusion. Each misread signal refines our tools, our patience, our humility. And yet, even knowing this, we keep searching. Because one day the pattern will repeat, not by accident, but by persistence. The spectral lines will align and stay aligned. The chemistry will shift and balance as if it is maintaining itself. When that happens, we will hesitate, as we always should, and then, quietly, we will open the window a little wider. Until then, the false positives are part of the conversation. the universe's way of reminding us that truth is a slow negotiation, and wonder is its translator. Each mistaken signal refines our vision. We're ready now to step back and see the pattern behind it all, the quiet logic that ties every world together. The story comes full circle in the dark. After all the centuries of looking upward and outward, the lesson returns to what has always been true: that life does not favor comfort. It begins where conditions shift, where pressure meets release, where chemistry is forced to choose between collapse and invention. The same edges that shaped Earth's earliest years, the boiling vents, the freezing tides, the poisoned air, are not exceptions. They are instructions. The pattern reveals itself across time and space. On Earth, life's first breath rose not in calm oceans, but in fractures between hot and cold, where minerals crackled under tension, and water learned to hold energy without losing it. It survived extinction after extinction by moving sideways rather than forward, into soil, into stone, into the darkness of the deep. Every catastrophe refined it, teaching resilience through constraint. What looked like near death was adaptation rehearsed. Elsewhere, the same logic appears. On Europa, heat comes not from sunlight, but from pressure. Tides grinding ice against rock until chemistry wakes beneath the surface. The moon's fractures act as gills, drawing oxidants from the crust into a hidden sea. The environment is chemistry still stirs. Heat rises from cores that never see sky. Convection folds the elements into slow cycles. These are not dead planets, only quiet ones, tuned to tempos we have not yet learned to hear. The lesson stretches backward to Earth's own turning points. Each catastrophe, the oxygen surge, the great freezes, the dying seas, forced evolution into corners where innovation became survival. Complexity was born not from abundance, but from scarcity. When the planet suffocated, cells learned to breathe. When it froze, they learned to wait. When it burned, they learned to change. Catastrophe is not the enemy of life, but its architect. If this is the pattern, then the map of our search changes. The right question is not, where is it comfortable, but where does the balance almost fail? The best candidates are the margins, the cracks under ice where chemistry and heat negotiate, the temperate edges of tidally locked worlds where dusk never ends, the coastal interfaces where liquid meets solid, where energy cycles between restraint and violence. In those unstable boundaries, equilibrium is constantly tested and maintained just enough for complexity to begin. The machines we've sent, Webb, JUICE, Europa Clipper, are designed to look for this balance. Their sensors trace the fingerprints of tension: oxygen without origin, methane without explanation, salts and plumes that repeat with suspicious regularity. They do not seek proof of life as we define it. They seek the conditions that make life's logic possible. The evidence they return will not give us an address, but a pattern, a list of harmonies and dissonances, of worlds that breathe between opposites. In the end, the answer is neither optimism nor doubt. It is method. We have learned that life hides not in perfection, but in negotiation, in places where destruction and creation share a border. The fragile film that first clung to rock, the bacteria that outlived cataclysm, the plankton that turned sunlight into atmosphere, the microbes that may still drift beneath Europa's ice, all are chapters of the same manual. The language of life is imbalance sustained over time. from 700D's horizon, past the pale glare of distant steam worlds, and finally returns to the thin blue film of home. It gleams against the void, fragile yet relentless, a reminder that the rarest thing in the universe is not life itself, but the narrow space where life can last. So perhaps the answer was never out there waiting to be found. It was here all along, in every place where pressure, chaos, and patience conspire to keep a spark alive.